Greetings to all the students. Our today's class is chemistry class and it is a very beginning topic which not only will help the students of class 6, 7, 8, 9 and 10 but also the students of class 4 and 5 because this topic of matter, solid, liquid and gases, properties of solid, liquid and gases, even the students of class 4 and 5 also have in their science books. So let's see what this topic is about. What is matter? States of matter, change of state, we are going to see in this chapter today. So matter is anything that has weight and it occupies space. Occupying space means volume. So everything around you, everything in the universe is actually a matter because everything has weight and everything occupies space. The three states of matter we all know: solid, liquid, and gas. Even the gas which we cannot see, like air is a mixture of gases. We do not see air, but air has a weight. It occupies space. If you fill a balloon with air and if you keep the balloon on a balance, it will show some mass. It will show some weight. And the space inside the balloon is the volume of air. So solid, liquid and gases all are actually the three states of matter. So in the universe, everything around you is either solid, liquid or gas. So they are all matter. So what matter, solid, liquid, gas are made up of? They are made up of tiny particles which are called atoms. So you can see in the picture in case of a solid, the particles are very much tightly packed together. Why they are tightly packed together? Because in between them there is a very strong intermolecular forces of attraction. Just like the small pieces of magnet stick with each other, the tiny particles in solid are sticking up with each other because of the attraction in between them. Since they are strongly attracting each other and sticking up with each other, they do not have any intermolecular spaces in between them. Since they have got a strong intermolecular attraction in between them, they cannot leave each other and they cannot run here and there. So we can say they cannot flow. You cannot put pressure on them and you cannot bring the particles more closer together. So we say, because they don't have any space in between them, so we say that the particles cannot be compressed. And the particles cannot move freely. So if movement takes place, if you hit a solid, if you heat a solid, the particles will start moving, but that movement is a very restricted movement and that is called vibration. What is vibration? The particles will just move left and right and they again come back to their original position. And we all know since our junior classes that they have definite shape and definite volume. The shape, the volume of the solids do not easily change. Similarly, liquids, another state of the matter is liquid. You can see in the picture that there are tiny gaps in between them. Why? Because the intramolecular forces of attraction are decreased. Weak intramolecular forces of attraction, that's the reason that they can relax now. They can move little bit apart from each other. They can create gaps in between them. Since there is less attraction in between them, so they can easily run around here and there. So we can say that the liquids can easily flow. They have a definite volume, but they do not have a definite shape. You pour the liquid in any container, it will take the shape of the container. But the volume of the liquid, if you put a liquid in a cup, a glass, a bottle, everywhere, for example, 1 milliliter of water will remain 1 milliliter. It is not going to change. So the volume will not change, but the shape will change. The particles can move freely because they have less attraction in between them, and you cannot compress them because the gaps in between the particles are so small that negligible compression is taking place, which we cannot notice. Similarly, gases, they have got no attraction in between them. The particles do not have any attraction in between them at all. So they can easily fly here and there. They have large gaps in between them. You can compress them at a large extent. They do not have any fixed shape. You put the gas, you fill the gas in a container, in a syringe, in a balloon. it will take the shape. The volume will also change. You can compress a large volume of a gas in a very small volume. So these are the properties of gases. Now the change of state, solid to liquid, liquid to gas. All right. So if you are going from solid to liquid, you have to increase the temperature. Liquid to gas, you have to increase the temperature more. If you have to convert, if you have to come back from from gas to liquid, you have to decrease the temperature. And liquid back to solid, you have to decrease the temperature more. All right. So how change of state is taking place? Change of state is taking place from solid to liquid, liquid to gas, and vice versa by the change in the temperature. So what will happen when you increase the temperature? You can see these are the two cubes of ice, and they are absorbing heat from the surrounding. And then the heat energy inside this ice will be converted into kinetic energy. The particles will absorb the heat, transform the heat into kinetic energy. Kinetic energy is the energy of movement. So with this energy, the particles start hitting each other, pushing each other, and at one stage, they push each other so hard that they create gaps in between them. This is called melting. Ice melts to water. Now you are heating water. You are boiling water. So when you will boil the water, again the particles will absorb the heat energy, will transform the heat energy into kinetic energy, and with this kinetic energy they start running here around the container here and there, and then they break up with each other, and then they fly in the air. We say that the liquid is evaporated, boiled away. Water has converted into steam. So water, liquid to gas, can be evaporation, can be boiling. So what is the difference in between evaporation and boiling? Evaporation takes place at room temperature. What happens after it rains? The water, the pools and puddles of water, they get dry up very easily. You do not have to heat them. Why? By absorbing the surrounding heat, evaporation takes place. But for boiling something, to boil a liquid, you have to keep it on the flame and you have to boil it. So boiling is taking place at a high temperature. We all know that the boiling point of water is 100 degrees Celsius. But evaporation takes place at the room temperature. If you throw some water on the floor, it will gradually, slowly evaporate and disappear, but it does not mean that the temperature of water will reach to 100 degrees Celsius. Why? Because evaporation takes place at room temperature. Now we are going reverse. We are decreasing the temperature. So when you decrease the temperature, you can see in the pot, we are boiling the water, steam comes out, steam touching the lid, and steam turns back into water. What does it mean? When a gas touches a cold object, it condenses. It converts into liquid. Why? Because when you decrease the temperature, the kinetic energy of the particles decreases. They start moving slowly and they come closer and they establish intramolecular spaces in between, intramolecular attraction in between them. And the intramolecular gaps reduces, and as a result, we say condensation is taking place and steam changes to liquid. Then you decrease the temperature more. You have got water now. You take this water and keep it in the refrigerator. What will happen? The temperature will decrease so much that the particles will come so close, their kinetic energy decreases that they hardly move at all. They stick with each other. And when the particles stick with each other, the gaps in between them becomes negligible. The liquid freezes to solid. All right. There is a graph over here, change of state curve, which shows how the temperature is increasing and the change of state is taking place. Now see, this is the solid object. Let's say it's ice. You are increasing the temperature, the ice is melting away. But at one stage, the temperature will not rise. The temperature will become constant. Why the temperature is not rising? Because change of state when takes place, the temperature does not rise or the temperature does not fall. Whatever the heat energy is going now in this solid, that energy is utilized in the change of state, not in increasing the temperature. So at certain point, for example, we have got a beaker. In this beaker, we have got ice cubes, and the melting process is taking place. We have got a container. In the container, we have water, and we are boiling the water. And if you dip the thermometer in the water, you will see the temperature will be fixed at 100 degrees Celsius. The temperature is not going to rise anymore unless and until the entire water will turn to steam, and then the temperature will start rising. So why the temperature is not rising? No matter you are boiling the water for the whole day and whole night, you put the temperature thermometer in water, you will see that there is no rise in temperature. It is fixed at 100 degrees Celsius. So where the actually the heat is going, the heat is absorbed by the particles, utilized by the particles in the change of state from liquid to gas. Once the entire liquid is converted into gas, then the temperature will rise. Similarly, the same case is taking place over here. For example, we have got a beaker of water. Sorry, we have got a beaker of ice. We have got ice cubes. Dip the thermometer here. It will show you 0 degrees Celsius. The temperature will be 0 degrees Celsius. Though the ice is melting, it's converting into liquid, but the temperature is not rising. And when the entire ice will convert into water, then the temperature will start rising from 0 to 1, 1 to 2, 2 to 20, 20 to 40. So where the heat is going, where the heat which is absorbed by the ice, where it is going, the heat is going in the change of state, is utilized in the change of state. So remember one thing, when the change of state is taking place, the temperature does not rise. When the entire solid will convert it into liquid, then the temperature will rise. When the entire liquid will convert it into gas, then the temperature will rise. This is the reason that you are seeing the rise in the temperature. Then is straight, no rise in the temperature. Change of state is taking place, melting is taking place. Once the entire solid has melted away, then the temperature will rise, and then the temperature will not rise. Why? Because boiling is taking place, liquid is converting into gas. When the entire liquid will be converted into gas, then the temperature will rise. So this is called the change of state curve. I hope you people have understood this idea. If you have any comments, any problem in understanding the things, you can write in the comments. I will be trying to give you the answer. Hope you will like this video. Bye bye.